Welcome back for day 2 of binomial radical expressions, section 6.3. Yesterday we focused on adding and subtracting these binomial expressions, while today we're going to move on to multiplication and division of these expressions. So I want you to think back to when we worked with polynomials. What strategy would we use to multiply binomials such as x plus 3 times 2x minus 5 or 3xy plus 1 times 2x minus y? Whenever we had two parentheses multiplying like that, we would use the process of foiling. And the cool thing is, the same thing applies when we're working with binomial expressions that use radicals. So look at this first example. So I have two parentheses, each with two terms, hence the name binomial. So I'm going to FOIL this out. First, so 3 times 5 is 15. Outside, 3 times the square root of 7 gives me 3 square roots of 7. Inside, negative square roots of 7 times 5 would be negative 5 square roots of 7. Negative square root of 7 plus square root of 7. Well, this time I'm multiplying the insides, so I'll have minus, and then 7 times 7 is 49. However, we know that the square root of 49 is really just 7. So when I'm thinking of combining my like terms here, well, we have 15 minus 7, so that's going to give us 8. But then we also have 3 square roots of 7 minus 5 square roots of 7. So 3 minus 5 leaves me with negative 2 of those square roots of 7. So notice the foiling process is actually quite perfect for this. And in the end, then you can always combine the like terms as necessary. So looking at our next example, let's FOIL this out. 4 times 5 is 20. 4 times 4 square roots of 2. So remember, multiply numbers on the outside, multiply numbers on the inside, but you don't blend. So 4 times 4 is 16, and then that doesn't impact our square root of 2. 2 square roots of 2 times 5. Again, multiply things on the outside, so 5 times 2 is 10, but that doesn't influence my square root of 2. And then finally, the trickiest one, 2 square roots of 2 times 4 square roots of 2. So again, remember, you multiply the outsides, so 2 times 4 gives us 8, and then you multiply the insides. 2 times 2 gives you 4. All right, now, however, I do want to point out that square root of 4 should kind of stick out to you. So that actually becomes a nicer number. Well, the square root of 4 is 2. So 8 times 2, that whole thing, we're really just talking about the number 16. So when I'm combining my like terms, 20 plus 16, well, that's going to give me 36. And then I combine my 16 square roots of 2 with my 10 square roots of 2. Well, that is going to give me 26 square roots of 2. And that's going to be as far as we can take it. So that is standard foiling. Now, we can take it a step further naturally. I hope you remember seeing stuff like this in Expo. When you had something squared, a parenthesis squared, what your teacher probably taught you to do is actually write it out. That squared means you have 2 of that particular parenthesis. Now when you write it out, it's much easier to see that this is a foiling problem, just like the previous ones were. So 2 times 2 gives me 4. 2 times the square root of 3 is 2 square roots of 3. Square root of 3 times 2 is another 2 square roots of 3. Square root of 3 times square root of 3 is the square root of 9. However, that should stick out to you. We know that the square root of 9 is just the number 3. So when we go to simplify this, to combine like terms, 4 plus 3 gives us 7. Then 2 square roots of 3 plus 2 more square roots of 3. That is going to give me a total of 4 square roots of 3. And that's going to be where we end with that one. Now, there are some special cases. Something called conjugates. Now, this is something that we visited, this idea we visited with imaginary numbers. Well, this idea comes back with radicals. Radicals have conjugates as well. So they differ only in sign of the second term. So when a and b are rational numbers, the product of two radical conjugates is a rational number. Now, you guys, again, you saw this when we were constructing polynomials. When I gave you a radical root, you took its conjugate. So when you constructed the polynomial, you had all rational coefficients. So the same thing is going to happen here. So just to revisit, just to show you what does end up happening, we're going to do two examples of simply multiplying conjugates. So I want you to notice they differ only in sign. You have 5 minus square root of 7 and 5 plus square root of 7. They differ only in that sign, but watch what happens. 5 times 5 is 25. 5 times square root of 7. Oh, I'm sorry, I wrote that wrong. Negative 5 square roots of 7, and then negative square roots of 49, which again, we know is 7. So look what happens. By having those opposite signs, the insides cancel. 5 square root of 7 minus 5 square roots of 7. So all you're left with are those outer terms, which give you a nice rational number. Let's say this happened again. 3 times 3 gives us 9. 3 times negative square roots of 8 is that. Square root of 8 plus positive 3. Then minus 64 when we multiply those two together. But again, we know square root of 64, we know that that's just 8. And again, notice, because of those opposite signs, because of those conjugates, those insides cancel, and all we're left with is 9 minus 8 to give us 1. So whenever you multiply two conjugates, you are getting a rational number in response to that. And that's going to be key. Because another concept that you should remember from exponential algebra, rationalizing the denominator. Now, we've touched on this a little bit already in section 2. Now it's coming back. However, it's slightly different. In section 2, I was teaching you to look for completing the denominator. However, that's when there was no addition or subtraction in the denominator. So these look a little bit different. These are binomials in the denominator. So the way to take care of that is by multiplying by the conjugate, which should be familiar after dealing with those imaginary expressions back in chapter 4. So if I'm going to multiply top and bottom by the conjugate, I'm going to be multiplying by the plus version of this. Okay, so the conjugate is going to be the plus version. So that is what I multiply top and bottom by. Now on the top, that simply distributes through. So 3 square roots of 2 times square root of 5, I can multiply those insides to give me 10. 3 square roots of 2 times square root of 2, again, I can multiply the insides to give me 4. So that was just distributing. On the bottom, however, it's not just distributing that we're going to be doing. This time, I need to FOIL it out. So, square root of 5 times square root of 5 gives me square root of 25. Square root of 5 times square root of 2 gives me 10, or square root of 10. Negative square root of 2 times square root of 5 gives me negative square root of 10. Negative square root of 2 times negative square root of 2 gives me negative square roots of 4. All right, so I've done the following process now. So let's take a look. Well, 3 square roots of 10, we can't really do anything with. However, the square root of 4, isn't that just 2? So here, we're getting 3 times 2 right there. Or I'm just going to jump and call that 6 for simplicity's sake. So that's what our top is. Let's look at what happened to the bottom. So square root of 5, or square root of 25, is just 5. Square root of 10 minus square root of 10. Just like we needed them to, they canceled off. Minus the square root of 4. Well, we know that the square root of 4 is just 2. So notice what happened when we multiplied by the conjugate. That bottom, we have 5 minus 2. So that's really just the number 3. We're dividing by 3. So we've successfully rationalized that denominator. However, I'm going to take this one step further, all right? Because notice, both of those numbers in the numerator are actually divisible by 3. 3 square roots of 10 divided by 3, well, just gives us square root of 10. 6 divided by 3 just gives us 2. So really our final answer for this one boils all the way down to just that. So let's do another example before we call it a day. So again, our goal is to rationalize that denominator. In order to rationalize the denominator, we need to multiply by the conjugate, meaning we have to flip that sign. So I'm going to multiply top and bottom by 3 plus the square root of 6. All right, on the top, that again is just a simple FOILing process. So we get 12x plus, and now really that 4x can't blend with the square root of 6 at all. So we're just going to leave it written that way. So the top is just distributing. The bottom, this is where our FOILing process begins. So I'm going to have 3 times 3 to give me 9. 3 square roots of 6, then a negative 3 square roots of 6, and then that last piece, negative square root of 6 times square root of 6, becomes a negative square root of 36. Notice, just like we need them to, those insides cancel out. So we have 12x plus 4x square root of 6 all on top. On the bottom, those insides cancel, so we're left with 9 minus the square root of 36. Well, the square root of 36 we more commonly know as 6. So what is that denominator? Well, 9 minus 6, I can just call that 3. And now this time, notice, the 12 and the 4, those are not both divisible by 3, so I actually can't simplify this one anymore. This time, it's left as a fraction. However, that is all right because the fraction that we're left with has no radicals in the denominator, and that was our goal that we learned in Expo and we revisited already in 6.2, just took it a little bit further here. So I realize this is a lot to take in. So please make sure you have all of this written out. And then once you do, you can wrap it up, come back to class ready to continue doing practice work.